Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. This time we are going to look at motion, but then you have to appreciate the fact that there are different objects and there are different kinds of motion. So the movement of a car, the movement of a tennis ball, the movement of a football, the movement of a bee, and the movement of a woman in a market trying to buy something. These are different kinds of motion. But then for further understanding, we are going to welcome you to this motion. Now, before we go into that, I want us to know that motion is defined as the change in position of a body with time. However, in this lesson, we are going to look at the definition of motion, list and explain different types of motion, and then we also explain the concept of relative motion and then define force and list the types of motion. Now, look at what is going on. I am sure you might have probably used this kind of motion, but then you are enjoying it, but do you know the kind of motion and do you know what is happening? However, this lesson is not to explain what is going on. It's just to tell you that there are different types of motion. So this is one of the motion, and the children on that seesaw, whatever, they're enjoying themselves on this kind of motion. Now, motion is the change in position of a body with time. You can see the car moving on the highway, moving from one point to the other and changing its position, and the time recorded with this change in position is what motion is. So whenever you're talking about motion, you are not talking about the fact that the body has changed its position and the fact that there is a time taken for a change of this position. Then you are not talking about motion. Whatever you're talking about is English or just a layman's understanding. As a physicist, the definition you have on the board is the perfect one for motion, at least for now and at your level. There are different types of motion. They include random motion, rectilinear, rotational, circular, orbital, spin, and oscillatory motion. I removed relative motion for an obvious reason. You'll find out why. Because relative motion is a broad topic which talks about reference, a position of reference, and which should be treated as a separate topic. And I'm here for you. We are here to cover you on that. Now, the first one we want to look at is the random motion. The random motion is the motion of a particle without direction. The movement of a smoke, the movement of a woman in the market, they go from one place to the other without direction, just trying to negotiate prices and all stuff. The movement of a bee, whenever there is a body moving without direction randomly, we say that such a motion is called random motion. The screen you're watching best explain what I mean by such a motion. The blue and the red balls or particles moving, hitting the walls of the container profusely and non-directionally is what random motion signifies. When we talk about rectilinear motion, this is a kind of motion of a body like the motion of a car from one point to the other. And as you can see, the car is moving from one place to the other, covering some poles. I see the poles and see the trees is moving past on a straight line. That's why we talk about rectilinear. Rectilinear. That is what it means. So we are talking about the movement of a body from one point to the other on a straight line. It's called rectilinear motion. So look at the rotational motion. There is a little misconception concerning rotational motion and circular motion. But however, rotational motion can be any kind of body rotating on a concentric circle. However, if we want to compare it with circular motion, you must know that such a motion must have a uniform speed and about its axis on a concentric form. But rotational motion, we are not going to consider a uniform speed. So it's just a body rotating about an axis. So this is what a rotational motion is. Example of such rotation is the fan of your blade, the wheel of a car or a bicycle, and many other kinds of motion. Now, orbiter. When we talk about orbiter, we are looking at a kind of moving body, for example, the Earth, the Moon, such that the body is moving on a given path. That path is called the orbit. Now, in an eccentric form, I am bringing this eccentric because it is not a circular. The orbit of a body is not a circle. It is an elongated circle with two different foci. When we are talking about this young man, this man, Kepler's law, you now consider there are two foci. Even though that this one, the first focus is where the sun is. This is the sun, and this is the earth, or the earth moving on this path round the sun. So we call it the orbital motion, because there is a path, there is an orbit for it to move, without which it will not go beyond it. And however, you can't say that this is circular motion, neither you can't say it is rotational motion, because at least from the center of the circle to this part is not constant, it's not concentric. So that is why we classify them under a part called orbiter. Spine, as you can see. So when we're talking about the spinning, this is what we mean by the spinning. That is an axis of rotation, and it is rotating in a vertical form about a given axis of rotation. And in a 3D shape, as you can see, the different axes, the X, the Y, and the Z axis. So this kind of movement of a body is called spine. It's not rotational, neither is it circular, neither is it orbital. Now, we also have another kind of motion, which is called oscillatory motion. Oscillatory motion. Sometimes we call it vibratory motion. They say that it's a to and fro motion of a body about a point, so that its displacement is directly proportional to this acceleration, and it is always directed towards the point, and we'll call it oscillatory motion. However, please, I am not defining simple harmonic motion, even though that this is simple harmonic motion. But then I'm talking about oscillatory, the up and down motion of a body. It can also be, this oscillatory motion can also be like the one we saw here. To and fro, to and fro. This is another kind of oscillatory motion. However, this is called oscillatory or vibratory. Now let's talk about force. What is a force? In primary school or in lower grade of your school, you learned that a force is a push or pull. Yes, of course, this is a push, and this is a pull, as you're watching on the screen. However, some changes to that definition has to be made in order to accommodate some basic concept that force can be defined with. We say that force is an agent, or any agent, which tends to change the position of rest or of uniform motion on a straight line. So we talk about the definition of force, or something that changes position of rest of a body at rest or in uniform motion. So the body may be at rest. That means the body is not moving. It is at a stationary point. But then something will hit it. Then we say that that is force. However, that is not only what force does. Force is not only making what is not moving to start moving. It is also making what is already moving to stop its motion. And that is application of brakes, which is a frictional force. So something that is already moving can also come to a stop with the help of a force. Now, there are different types of force. Now, the first one is called contact force, and the second one is called force field. Now, what is a contact force? As you can see, the young man using the pump and then apply the force at the end, the handle, and is pushing the air down in order to inflate the tire. Now, a contact force is that kind of a force applying on a body with a contact. That means there must be a contact at which the force is intended to be applied. That is contact force. However, another kind of force is not contact. Now, but before that, let's talk about some examples of contact force. Push is an example of contact force. Pull is an example of contact force. Which other one? Like we talk about tensional force is a kind of contact force. I will say frictional force is also a contact force. I will also say reactional force is also example of contact force. So these are different kinds of contact force because at their point of application, there must be a contact. They don't just act spiritually as in quotes. But the one that is in that form of spiritually no contact, you can even imagine how it works. It's called force field. Force field is a kind of force such that there is no contact at the point of application or its application. For example, this, I am holding it because force is holding it. If I let it go, something pulls it down. Whatever that pulls it down is a force, but that force is called force field because there is no contact in bringing it down. Another one is a magnetic force, as you are watching on your screen. You see, it is pulled to this part, and when it is left, it is pulled back when they are of the same polarity. I mean, when they are of different polarity, when they don't have the same charge. But when they have the same charge, they separate. So force can pull, it can also repel. These are all what forces can do. Now, we are going to look at a few calculations about force. We are going to look at a few of them. Now, but before that, I don't want to be pushed into start proving the rules for second law of motion, or which is called change in momentum. But I think I have a little to talk about it. We say that force is given as ma. The force is given as mass times acceleration. That came from this, which is called impulse. Impulse, which is something as change in momentum. We're going to look at that maybe in the next lesson. If you check the next lesson, you will see them. However, if I take t to both sides, you say that m v minus u over t, such that, remember, acceleration is given as change in velocity per time. So if I take this away, we say that F is equal to ma, which is called change in momentum. The rate of change in momentum is force. That is according to the second law of motion. However, look at the question on the board. We have established the fact that this is force and it came from momentum. We arrive at that point. So let's talk about it. How can we simplify this problem? You say a 900-gram stone is pushed along a tarmac by a horizontal force of 20 Newton. A frictional force of 8 Newton opposes the motion. What is the acceleration given to the stone? Now, let me show you what happened there. You see, a stone is pushed along a tarmac and a horizontal force of 20 Newton. All right, see. This is what I mean by that horizontal force. See, you see the way that force is pulled. You see the way they pull this force. That is what I mean by the horizontal force. Pull, it is pulled in that direction. It is pulled. And this This kind of instrument is called spiral spring. It is used in measuring the force on a body. Spiral spring, look at it. Now, going back to that, and that is just what happened. So, a body of mass, 900 grams, was pulled on a horizontal direction. Then let's go to the solution. So, look at the body here. And then this is the hook. And this is using to pull it. So, when they pull it, and this is 900 grams, I have to convert it to kilogram. So, let's get started. According to second law of motion, okay, let's first talk about the horizontal force. The horizontal force is 20 Newton. 20 Newton is pushing it in this direction. Then you know what frictional force must always do to oppose the force. It must be there to oppose the force. And the frictional force of 8 Newton is moving in this direction. That means there is a vector, a change in force. Therefore, how then do I solve it? So, according to second law of motion of physics, we say that F minus this frictional force, I'm using FF as frictional force, is equal to the force. Because, you know, change in force is going to give you the same force. So, the force is mass times acceleration. But then this force is the applied force. Let me put it FP, which is equal to this one, FP. That is the applied force. And this is the FF, which is the frictional force. So the applied force, because you see at the end, this body will still move in this direction, irrespective of the frictional force. It's just like a human being. You are trying to succeed in life. You are trying to do something. You are trying to succeed. But there are a lot of forces pulling you down. But at the end, you now rise against the odds and move in the direction of your success. That's the same thing happening here. There is a force pulling here. And that is only when you gather a lot of force that is bigger than the forces trying to keep you down. That is how success is built. So there is a force of 20 Newton moving in this direction on that x-axis. And there is another force which is not up to this force. So it's moving in. So I'm going to do a change. There is going to be a change in force. So I'm going to put 20 minus 8 is going to be 900 all over 1,000. Wow, why 1,000? I have to convert it to kilogram because that's my SI unit. Then times the acceleration, which is A there. This we cancel this. This we cancel this. This is 12 is equal to 9 over 10 times A. I have to clear fraction. Multiply this by 10. Multiply this by 10. 10 we cancel this 10. We have 120 is equal to 9A. 9A. So A it becomes 120 divided by 9. Okay, please, let's 13.3. So 120 divided by 9 is 13.3 meter per seconds square. This is the acceleration. That acceleration is the rate of change in velocity of the body on that direction. Just like this, which I showed you earlier. Let me show you. Just like what happened. The body takes and moves in that direction with that given acceleration by that force. So let's look at the second question. Look at the second question. A car of mass 800 kg, you see at this point, they didn't give us in grams, they gave us in kilogram, moves from rest on a horizontal track and travels 60 meters in 20 seconds with uniform acceleration. Assuming there were no frictional forces, of course, there is no frictional force at this point. So at this point, a mass of, now before we go into that, a car moves from rest. Rest means that initial velocity is 0. That means the speed at that point at time 0 is 0 meter per second. Meter per second. Then the distance traveled is 20. So if you have displacement which is 60 meters or distance which is 60 meters and then time is 20, that means that the final velocity is going to be 60 over 20, which is 3 meters per second, which is the velocity at that point. I've taken velocity, right? Now for us to find the force, You can't move this and then, okay, calculate the force. Therefore, force is going to be MA. So force is what I'm looking for. Mass is 800 times A is V minus U over T. Now, which is given as acceleration. However, for you to be able to find acceleration, you have to say that acceleration is change in velocity over time. Velocity is 3 over time is 20 seconds. 8 times 3 over 20. This is 40, 120 Newton. That is the force on this body moving. We have come to the end of this class, but before we go, you have to follow me to Examguide app where we are going to see varieties of questions. Let's get started. So, at this point, we have this question say, which of these is a contact force? Of course, remember what I listed. If you can go through the video, we have frictional force, electric force, never. Frictional force is the only contact force based on what I listed in the lesson. Because this one does not need contact, it doesn't need except that. Let's move to the second one. What type of motion do the wheels of a moving car undergo? The wheel of a moving car, two things. It is rolling, but it is still moving from one point to the other. So I'm going to say rotational motion and what? Do I have translational? Good. So it's rotating, the wheel of a car is rotating, yet it's still moving from one place to the other. So that is what I'm going to choose. And B. No, I'm not talking about graph. I'm not talking about graph. Which of the following bodies exhibit translational and rotational motion at the same time, that is simultaneously? Books slide down in an inclined plane. No, it doesn't rotate. A stone released from the top of a cliff. A butterfly hovering over a flower. A cylinder rolling down an inclined plane. Yes, that is it. Just like the wheel of a car. It is rolling, yet it is moving from one place to the other. Just like a wheel, you know. So that is the best explanation for that. When a ball rolls on a smooth level ground, the motion of its center is rotational. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.